Hi guys, let's do asteroid collision. So we're given an array asteroids of integers representing asteroids in a row. The indices of the asteroid in the array represent their relative position in space. For each asteroid, the absolute value represents its size, and the sign represents its direction, positive meaning right and negative meaning left. Each asteroid moves at the same speed. Find out the state of the asteroids after all collisions. If two asteroids meet, the smaller one will explode. If both are the same size, both will explode. Two asteroids moving in the same direction will never meet. So we're given three examples down here where in example 1, we are given an array, input array asteroids equals 5, 10, -5, and we output 5 and 10 because basically the 10 and -5 collide, representing in 10. So if we loop through this array, so we have 5, which is fine, and then we have a 10, which is fine because 5 and 10 are the same sign, so they're going the same direction, they're both going right, so they never collide. Then 10 and -5 here are going in opposite directions. 10 is going right, -5 is going left, and so they collide. And then because 10 is bigger than, like, the absolute value of each of these are 10 and 5, right? And so 10 is bigger than 5, so the 10 is the one that survives the collision, and the -5 will explode. So we're left with 5, 10. And in example 2, we are given this array of 8 and -8, and we output an empty array because the 8 and -8 collide with each other, and since they have the same absolute value, both of 8, they both explode. So we're left with nothing. In example 3, we are given this input array of 10, 2, and -5, and we output 10 because, so for this one, first the we have a 10, which is fine. We have a 2, which is fine because these are both going in the same direction, and so we can put 10 and 2, and then we reach this -5. 2 and -5 are opposite signs, so they're going to collide. And then we realize that the absolute value of -5 is greater than 2, so the 2 will explode, and we are left with -5, so we can put this -5 here. But then because 10 and -5 are going in opposite directions, then they will also collide, and so the 10 has a greater absolute value, so the 10 is the one that will survive. The -5 explodes, and then we're just left with 10. So yeah, so we continue to, like, if we remove this one explodes, then we continue to do that until we either have the same sign or there's nothing left to collide with. Now, the one thing to keep in mind for this problem that is kind of weird, and they don't mention it in the problem, is that, so if we only have a collision if the first asteroid is moving right and the second asteroid is moving left, because if the left asteroid is moving left and the right one is moving right, then they're still never going to collide because they're moving away from each other, not towards each other. So that's just another thing to keep in mind for this problem. But to solve this problem, we are going to need to loop through each integer in asteroids, and we'll probably want to add them to a stack so that as we add them to the stack, then we can compare the top element of the stack to the next asteroid and compare their signs and values to see if we should pop the top element on the stack, which would mean this asteroid exploding if that's the one on the top, or pushing our new element if it's the same sign, or just destroying the asteroid that is not in our stack and then continuing along the array. So let's create our stack of integers. And then we're going to want to loop through our asteroids. So I'll just do a for each loop. Okay, And then here, so while our stack is not empty and our top element of our stack is positive and our current element is negative, because that's the only way that they will collide and we will want to compare them. So, and greater than 0 and asteroid is less than 0. So the reason I'm doing this is because if our stack's top element is, like, let's say we're currently at this -5, we just pushed this this +2, then we would be entering this while loop, right, where we do not have an empty stack. Let's make this a stack. So in our stack, right, it's not empty because we already pushed the 10 and the 2. Oops. And our top element is positive, it's greater than 0, so it's moving to the right. And the asteroid, which is our current element, which is this -5, is less than 0, so it's moving to the left. That means these two asteroids are going to collide, right? So then we need to do some work to figure out what we're going to do in that situation. So first of all, if our top element has an absolute value that is greater than our asteroid, then that means this one is going to be the one that is not going to explode. So we want to leave that, and we want to skip over this asteroid. So if our top element is greater than the absolute value of this one, which would be the negative of it, so a negative asteroid, then I'm just going to I'm going to use the numbers here as the size of the asteroid, so 10 or 2 or 5 or whatever, like the value, you know. But if that asteroid explodes, I'm just going to say it's size of 0, so we'll just assign it to 0 for now. And then we'll want to break out of this loop so that it, like, let's say there was more elements down here, like 10, let's not use 10 again because we already have a 10, like 8, -6, right? Then, like, we're going to want to keep moving along to the, we're going to want to skip to 8 after this. We're not going to want to keep looping with the same asteroid. So we're going to break out of this. Otherwise, so this was if this number is greater than this number. So that means the second asteroid is exploding. So the other possible case is that they're the same number, like for this 8 and -8, right? Like if we have that, then we'll say stack.peak is equal to negative asteroid, because they're the same in value but opposite in sign. So if that's the case, then both of them explode. So we'll remove the one that's on top, and we will also explode our asteroid. So asteroid is also 0. And then we'll want to keep looping because, like, let's say we have 8 and -8 like that. Oh, let's change this number so it doesn't all explode together. Then that means we would have pushed 10 and then we push 8 and then we're at this -8, right? So we will we'll pop this 8 and then we will set this asteroid to 0. And then that way we'll do a check at the bottom, but we will just keep looping. So, like, then we'll skip to this one and then we'll compare the 10 to this 7 and then we'll probably push the 7 and then we'll keep moving, and, like, you know what I mean? So, okay. Then else, so our only other case, if the top element in our stack is not greater than our asteroid in value, or if they're not equal in value, then that means this one must be less than this one in value. So that's the last case. And if that's the case, then we will want to remove the top element in our stack. So we'll just say stack.pop, and that will be it. And then we'll want to keep looping again because, again, like, let's say we have 5 or something, right? I don't know. like, let's just say we have that, and then we have -9 or something, right? Like, so we will pop this value. Like, let's say we're at the -9, we just added 5. And then we're comparing the 5 to the -9. So if that's the case, we will enter here and we will pop the 5, and then we will keep moving along. So, and we'll keep looping. So then we'll want to check the 9 and like so -9 and so on like that. So, yeah, once we have done all of this and we exited the loop, so we're done comparing, then we're going to want to check if our asteroid is not 0, then, so like it didn't explode, then we're going to want to add that to our stack. So stack.push asteroid. And then we're going to basically do that for every asteroid in our array. And then once we reach the end of the array, then like let's go back to example 1 just to make this simple. So then our array will look like five and 10, or our stack, I mean. But we don't want to return a stack, we want to return an array. So we need to be able to convert this stack into an array. But so we need to do it in reverse order, because from stacks, we can only remove the top element, which would be the last element that we added. So if we just directly add it to an array, it's going to be in reverse order. So we're going to have to add them into the array in reverse order. So let's make an array called result is a new integer array of the same size as our stack. And then for I is result.length -1, I is greater than or equal to 0, I minus. So we're just going to add them in reverse order. Then result at I is stack.pop. So we're just moving all of our elements into the array, and then we're going to return our array. So, okay. And then our time complexity is O of n, where n is number of elements in asteroids, or our number of actual asteroids, because we need to loop through every single element in our input array to check what we should add to our stack, like which asteroids are going to explode, basically. And we do that in this for loop, this for loop. And then we have another loop, which is also O of n, where we just move all of our asteroids into our from our stack into our array. So O of n plus n is O of 2n, which is O of n. And then space complexity is also O of n, which is the same thing, because we have a stack where we, worst case, like if nothing collides, we're going to add every single element into our stack. And then same thing down here, right, where we have an array where we, well, technically you don't count the result. Like if this is part of the output, then I don't think you include that in the space complexity, but this would be O of n. But either way, so our stack is O of n, so it's O of n. So that's it for this problem. Thank you guys for watching, and let me know what I should do next. Bye.